So initially we were trying to understand what is Docker, correct? First of all, what is container? What is container? Container is like a virtual machine. Virtual machine in which you can do everything, like you can deploy any kind of application, just like EC2. What is Docker? Docker is a tool or software by using which we can create these containers. So by using Docker tool, you can create any number of these virtual machines. These virtual machines we call containers. What is the main purpose of containers? In order to reduce the bill. Instead of using EC2 instances, we can use containers so that we can reduce a lot of bill, huge amount of money. In that, I told you, right, Docker is all about three main keywords. That is OS level virtualization, union file system, and layered file system. Yesterday, we have seen already what is OS level virtualization. OS level virtualization means containers are depending upon, here, containers are depending upon base machine's OS virtually. Okay. Containers are depending upon base machines 99% Unix virtually. That is what we call OS level virtualization. That means if you want to launch any container, you need to have Docker image first. Docker image means OS only, but only that 1% OS. Okay, 1% that particular OS feature, Red Hat, CentOS and all. But we need remaining 99% Unix also, that will be taken from base machine. Understood? So every container is depending upon base machines 99% Unix. Virtually, they are not physically grabbing it, physically taking, no. That depending upon base machine OS virtually. That's what we call OS level virtualization that already we have seen in our previous class. Okay, right. Coming to remaining two keywords that we need to understand. That is layered file system. Layered file system. Let's say this is my Docker Hub. Docker Hub or Docker registry we can call. Here we have images. CentOS, Ubuntu, Red Hat, images of only 1%. 1% that particular OS features. Now what I'll do, I take one image. This is an image. Let's say Ubuntu. Okay, from Docker Hub, I have taken this image. From that, I have created my container. Okay, I have created my container. Guys, in companies, generally what we do, if you observe carefully, in order to have Docker containers, you need one base machine. That too mainly Linux machine, correct or not? In order to have container, we need one base machine, right? Right here. In place of this, we launch EC2 instance. Instead of launching multiple EC2 instances, we launch one EC2. On top of that, we install Docker. Then we create containers. Understood? This is what we do in companies. Okay. So we are going to launch one EC2. EC2, let's say Amazon Linux, I have taken. Hardware is with AWS. This particular EC2 physical machine is with AWS. Correct or not? Right? And we are taking Amazon Linux. So Amazon Linux has 1% Amazon Linux features, 99% Unix features. We are going to install Docker on top of that. Then we are going to create containers and we are going to use them. That is what we are going to do in companies. Everyone understood or not? But this particular one, please confirm yes or no, understood or not? Understood? This is what we are going to do in companies. Got it? Yeah, remember that. If you don't have Docker, then you might need to use lot of so many EC2 instances. The way we are using containers, right? In those many instances you should launch if you don't have Docker. But here with just one instance, we are having many containers. That is how we are saving a lot of money. Here what we do, we are going to take one image and we are creating container out of that. Let's say this is container 1. Now what I do, I go inside the container. It's like a normal instance only, right? Virtual machine having OS, right? OS means that's what, only 1%. 1% Ubuntu features. 99% will be taken from base machine, Unix, that already you know. So after going inside, I can do whatever I want. Let's say I have installed some package. I have installed HTTPD. I have installed any package, let's say tree. Okay. So in Ubuntu, we use this one, right? Apache to install HTTPD, we use Apache to correct on web package name. Tree package, let's say I have installed Git package. I have created one directory, let's say one directory. I have created one file. I did so many things. So whatever you do inside container, that forms a layer. that forms a layer, one on top of another one. Inside container, whatever you do, each and every activity forms one layer. That's why we call it a layered file system. Layered file system. Why we call layered file system? Inside container, you do anything. Each step, each activity forms a layer, one on top of another one. Got it? You install package. That is one layer. One more there is one more layer. So each one is a kind of one layer. That's why we call it as a layered file system. Got it? Now, assume that in our project, we all are working in one project. Assume that you are 100 members plus myself. I'm your team lead. Assume. Okay, I'm your team lead. In order to work in one project, our project requirement is such that everyone should have one container. That container should have some 500 softwares. Okay, 500. Okay, so okay, let's take these 4, 3, 4, 5. These 5 should be there, everyone's machine. These 5. Okay, 3 packages, 1 directory, 1 file. Assume. So, in order to work in a project, requirement is the project requirement, everyone should have one container. We are going to work in that containers, our own containers, and everyone's container should have these 5 components, these 3 packages and 2 directory, these directory and file. Now what you can do, you can create your own container. You can take one image from here. You can create your own container. Inside you should install these packages and you should create these files and folders. But some of you might take older versions of these packages. Some of you might take wrong versions. Some of you might get some errors while installing. Some of you might give wrong directory names, wrong file names. So you might create in wrong locations. That means everyone's container will have different environments. Everyone's container. In fact, that's a hard work also. Again, I need to inform them, hey, you did wrongly. Hey, you have taken wrong version. That's a hard work. But here there is a smart work. What is that smart work? Assume that this is my container. Let's say Sai's container. Being a team lead, what I'll do, I take one image, I create one container. Being a team lead. See, I have installed 3 packages, I have created these 2. From this container, I'm going to create one image. This image I have taken from Docker Hub. This image is having only OS, 1%. That is only OS. That is image A. The image B. From this container, I'm going to create one image. This image consists of this OS, Ubuntu, plus all these 5. These 3 packages, this file and the folder. Understanding, right? So from container also we can create image. When you create an image, that image will have OS plus the entire data, be it package or file, directory, whatever. Got it? So I'm going to create one image. Okay, let's say this is image A, this is image B. This image I'm going to share with all of you. When you get this image, what you do? From this image, you are going to create your own container. This time you are going to create container from the image which I have shared with you. So this image will have OS plus some additional things as well. You create your own container. Let's say your container. When you go inside container, yes, you will see these 3 packages and this file and folder. This Apache to tree, gate to directory file. Now everyone's container will have the same environment, same package with the same version, with the same file folder in the same locations, right? This is the smart work. Understood? That also we can do in Docker. Got it? So you don't have to install all of them. No. I create image from my own container. I share that image. From that image, you just create a container. That's it. Got it? Now, suppose if you want to add some additional packages, yeah, you can go inside container, you can do some additional activities. You can uninstall existing things. If you want to uninstall Git, you can uninstall. If you want to install some other package, yes, you can install by going inside the container. That means when I share an image, from that you can create a container. By going inside container, you can do whatever you want. You can add some additional package. You can uninstall existing package. You can create or delete existing files. You can do. But what you cannot do is modifying the image as it is. Okay. Without creating container, without going inside container, you can't edit image. Like just like say, this is a pen drive I'm sharing with you. This is a pen drive. Can you edit pen drive as it is? You know that inside pen drive you have some data is there. Can you edit? You have 5 movies are there. Can you edit? No. If you want to edit, you have to attach to laptop. You go inside laptop. Then you can either add some data or delete existing data. You can do. But you can't edit pen drive as it is. Correct or not? Right? Right. You cannot edit the pen drive. In the same way, here you can't edit image as it is. No. You can create a container. By going inside container, you can do it. Right? So why you can't edit image? Why you cannot edit pen drive as it is? Because you don't have any such feature of editing pen drive. Correct or not? Here also, why you can't edit image? Because in a image, these layers, they form unity. Unity or union, you can call. Unity is strength. Union is strength. Correct or not? You can't break that unity. So here also, these layers, they form unity when it is in image format. That's why you can't edit this one. Got it? That is what union file system. When it is in container, we call layered file system. When it is in image format, we call union file system. Simple. Got it? That is how things work. Clear? Now let's talk about the benefits of Docker. I hope you understood. Union file system and layered file system. I told you, right? Docker is all about 3 keywords. You can see OS level virtualization. Containers are depending upon base machines OS virtually. That's what OS level virtualization. Also we call containerization. Docker uses union file system and layered file system. Union file system, layered file system means when it is in container format, each activity forms a layer. Right? That's why layer file system. What is union file system? In image, you can't edit image as it is because inside image, all softwares, files, folders and all, they form unity. You can't break that one. You can't edit. That's why we call it as a union file system. Understood? Right. Already you understood the differences between VMwares and Dockers. Now, what are the benefits of Docker? First one, containerization. Also we call OS role virtualization. That is the first benefit. What are the advantages here we are getting? Here, we are saving lot of storage. Correct or not? In this containerization, OS role virtualization, we are taking lot of storage. Why? Because containers are not having OS. 99% Unix. They are depending upon base machines OS. Right? That's what. You can see no need guest OS. You don't need to have OS of 95% Unix. That means here we are saving a lot of hard disk. Second advantage, no pre-allocation of RAM. Already I have explained in yesterday's class. During runtime containers, they take the RAM from base machine, whatever they need. After that, they releases that RAM so that other containers can use. So these are the major advantages of Docker as we discussed in our yesterday's class. You can see here, we are saving hard disk and RAM. That we are saving here. Lot of hard disk and lot of RAM. Okay, those you have to explain at the beginning. Okay, those you have to keep at the top. Then many other advantages. Can replicate the same environment. Can replicate the same environment. That means whatever we have discussed today. Right? Every one of you should have one container with the same environment, whatever I have. So what we can do, instead of you creating your own container, I create one image from my container, I share that image with you. From that you create containers. That's it. Whatever environment that I have, you also will have the same environment. Correct? Right. That is what. We can replicate the same environment. Less cost. Why less cost? Because you are saving lot of hard disk, lot of RAM. So obviously RAM and hard disk, if you are saving means you are saving lot of money. Correct or not? If you want more hard disk, more RAM, you need to spend more money, right? In AWS, if you want to take higher configuration, let's say T3 micro we have taken. If you take higher configuration, you will huge amount of bill. Lightweight, MBs in size. Well, lightweight means what? Lightweight means here, containers are having only 1% OS. Lightweight, not 95% Unix. Okay, lightweight means less OS. That is the meaning of lightweight. Understood? So lightweight means less OS. Means indirectly the size of the OS, the storage it is consuming overall itself is less. Okay, indirectly only whatever software you are going to install, right? That software size only, the storage, whatever softwares are consuming, that much only. Not OS, right? In that sense, lightweight, MBs in size. That's what, that OS, 60, 70 MB only. Okay, but if you take VMware or Oracle VirtualBox, it will be having 5 to 8 GB, 5 to 8 GB, right? That is one difference. Then fast to fire up. Fast to fire up means quickly you can start. You can start quickly. Means here already 99% OS is running. You just have to start only 1%. That's why container creation is pretty fast. In fact, it's second. It takes less than a second to start a container. To launch a container, it takes less than a second. Fast to fire up. You can start quickly because 99% is already running. Base machine is running. You just have to deal with only 1%. That's why pretty fast. Then can run on physical, virtual or cloud. Any machine you can run. That means, see, right now what we are going to do, we are going to launch one EC2 instance. We will be installing Docker and we are going to create containers. So these containers are running on cloud machine. This could be your physical laptop also. Let's say I have my laptop, Linux laptop. I install Docker, I create containers. This could be physical or cloud machine or virtual machine as well. In the sense, generally we don't do it, but could be virtual machine as well. These are virtual machines, VMwares, Oracle VirtualBoxes. Here I install Docker here. Here I create containers. These are running on virtual machine. That also you can do. Doesn't matter. Any underlying setup, doesn't matter. Can reuse same image again and again. Yeah, very, very important. Here, observe carefully. Can reuse the same image again and again. Here, I have used image like this, but actually what happens, when I share image with you, from that image, when you create a container, what actually happens? It takes a copy of that image. Then container will get created. You will not use that image as is directly. No, image will not get engaged. No. Whenever you create an image, let's say how shared image be, assume this image be. When you create a container, it takes a copy of that image. From that container will get created. So that from that image, you can have one more container. Every time you create a container from the image which I have shared with you, that container, before it gets created, it takes a copy of that image. From that container will get created. That means from one image which I have shared with you, you can create any number of containers because every time it is taking the copy of that image. Understood? Right. That means you can reuse the same image again and again, this one. That means from one image, you can create any number of containers. Can create machines in less time. That's what, within fraction of seconds. I told you, right? Container creation, it takes less than a second. I'll show you that one. So these are the benefits of Docker. If at all they ask you, hey, what are the benefits? You have to explain all of them. That too, you have to keep these two at the top. Saving lot of storage, hard disk, and saving lot of RAM, memory. You have to keep these two at the beginning, then remaining two later on. Priority is pretty important here. Got it? Then, Docker components. What are the components of Docker? See, Docker image. What is Docker image? Sometimes it contains only OS. Sometimes it contains OS plus softwares, correct? OS means what? That too, only 1% OS only. Very small, almost negligible. 1% of OS features. You can see. Docker image means what? Sometimes it contains only OS. Sometimes OS plus softwares. You can see. Image A, having only OS, 1% Ubuntu. Image B, OS plus some softwares, correct or not? You can see. So Docker image means either having only OS or OS plus softwares. That too OS is negligible, that is what Docker means, which is used to create container. That is the first Docker component. Next, Docker container. What is container? Container is like a machine. Like a machine we create from the Docker image. Correct? That is what container. Okay, container is like a machine which we create it from Docker image. Then Docker Hub or Docker registry. You can say Docker Hub or Docker registry stores all Docker images publicly. See here, Docker Hub or registry. It stores all Docker images publicly. Means anyone can pull the images. The way I have pulled, right? Anyone can pull these images, which contains images publicly. Images mean what? That's what OS only, but only that 1%. That is what Docker Hub or Docker registry we call. Then Docker daemon. Docker daemon means what? Docker service. After installing Docker on top of your EC2 instance, you have to start Docker service. Docker has its own service. That is what we call daemon. Daemon means backend service. Just like the way we install HTTP, we start HTTP service. Docker has its service. We have to start this service. That is what we call Docker daemon. So till the time Docker is running, you can handle these containers. Okay, you can manage either creating, editing, deleting, everything we can do. Then say what is Docker file? File, it describes steps to create Docker image. It describes steps. That means if you observe carefully here we are getting how many images? Here we are getting image A, image B. Okay, better I will write here. This is image A. This is image A. This one. This is image B. Correct? So you got image A from Docker Hub. You got image B we have created from our own container. Right? There is one more way through which you can get Docker image. There is one more way. What is that? Docker file. There is something called Docker file. Okay. In which what I do, I mention every detail, like which OS you want. I want. What are the softwares I want? Let's say I want some 6 softwares. So Docker file is a normal text file in which we mention required OS and required softwares, whatever I want. From that image, from the Docker file, we can create our own image. Let's say image C. This will have this OS plus all these softwares. Got it? This is the third way through which we can get Docker image. First way is what? Pulling image directly from Docker Hub. Focus on my green color. First way is getting image from Docker Hub. Second way is creating image from our own container. Third way is creating image from Docker file. Docker file is a normal text file having instructions in it. Instruction means what OS you want, what softwares you want, everything we mentioned here. From that, we will create our own image. That is image C. There are total 3 ways through which we can get Docker images. All right, remember that. So that is what Docker file contains steps, describes steps to create Docker image. Yeah, this is workflow of Docker. I mean, this image you will get from Google also. Docker workflow diagram. This is the same one, you can see. This is the same one which I have used. Whatever you are seeing, that is the same one. Okay. Let's say she is a developer or DevOps engineer. She is a DevOps engineer. What she is doing, she is creating Docker file. I told you right just now, Docker file means what? Inside we mentioned what OS we want, what softwares we want. We mention all the details. From that, we can create Docker image. Already you know just now we have discussed. Right. From that, we can create our own container. Right? Suppose if I want to share this image with you, what I do, I upload to Docker Hub. My image I upload to Docker Hub. Let's say we have 2 guys in our team, Mr. A, Mr. B. So Mr. A will pull this image from Docker Hub, this image, this one. From that, he will create his own container. Mr. B, he also pulls that image from Docker Hub. He will create his own container. Like, got it? I create Docker image. I create container. This image I upload to Docker Hub. From there, you can pull that image. You can create your own container. So, this container container X, container Y, container Z, all will have the same environment. Got it? That is how we can do. And what are the ways through which we can create Docker images? What are the ways? Total 3 ways, as I already explained here. First way is get image from Docker Hub. This one, image A. Second, Get image from our own container, image B. Third, get image from Docker file. Correct? Total 3 ways. Right, you can see. You get image from Docker Hub. Create image from our own container. Create image from Docker file. There are only 3 ways through which you can get Docker images. Understood? Right. So this is the theory part of Docker. I hope you understood. It is pretty easy. Unlike Git, Git is a bit confusing, but here, trust me, it is pretty easy and pretty easy commands. Fine. So what all we are going to do practically, theory, lab, what we do, simple, as I already explained, we are going to launch one EC2 instance, Amazon Linux. Okay. We are going to launch one Amazon Linux EC2 instance that has 99% Unix. Right. Fine. So we are going to install Docker in it. We'll be starting Docker service and we'll be managing all these containers. This is what we are going to do. Understood? Right. Yeah, then let's do it. Let's do it. Log into AWS account. Everyone understood theory part or not? Please confirm, type yes or no. Right. Yeah. Thank you. Thank you all. Enter MFA 309. That's it. We are in Mumbai region. Now go to EC2. Let's launch one Amazon Linux instance. Let me delete all existing key pairs and security groups to avoid confusion. So this is your previous class key pair. Let me delete. Security groups. Select. Delete. Delete. That's it. Now go to dashboard and hit refresh. Fine. We don't have anything. Even let me delete these keys also. Keys folder. Let me delete these 2 keys as of now. Fine. Yeah, let's launch one Linux instance, launch instance. Give any name. I'm giving Docker. Okay, Docker. Amazon Linux. Going forward, we'll be using other operating systems as well. Even in Docker also, in some places, we'll be using Ubuntu. You can use any OS, any base machine. That is up to you. T3 micro, that is fine. Key pairs, let's create a key pair. I'm giving name called Docker. Docker 7 a.m. Docker 7 a.m. PEM file, create key pair. Then security groups. As of now, we need SH and HTTP. Select both of them and give any name here. Edit. Any security group name. I'm giving Docker 7 a.m. Okay. Security group. Then storage 8 GB is fine. That's it. All good. Now launch instance. And view instances. Now go inside this instance, connect. Username @ DNS name. Sessions, new session. SSH. This key pair, let's keep it in a safe location. Always have a habit of keeping key pair in a safe location. This is my key pair. Right. Cut from here and paste here. Okay, that's a good practice always. Now upload our key. Docker 7 a.m. That's it. So we have logged into our instance. Okay. Now clear the screen. Sudo su minus. That's it. Now we are going to deal with lab. Okay, as I already explained, simple guys, pretty simple. These are EC2 instance, right? Okay, Amazon Linux means having 99% Unix, correct? We'll be installing, these are EC2. We'll be installing Docker now. Then we are going to create containers. This is what we are going to do. And we are going to see all container related activities. Simple lab. Got it? Pretty easy tool. Docker is pretty easy.